So what I want to make today is something called Risset rhythms. You may have heard of shepherd tones, which are like these tones that seem to rise or fall infinitely, but they're actually just looping. And there's something similar called Risset rhythms, invented by Jean-Claude Risset, I guess. A rhythm in which tempo seems to increase or decrease endlessly. You can hear an example of this kind of thing in a song by Autechre. It's called Fold4 Wrap5. It's got this beat that seems to slow down and keeps slowing down. So inspired by this, I want to make something similar in SuperCollider. I'm gonna boot the SuperCollider server. And we're gonna start making some sounds. I'll just start off with a simple hi-hat kind of thing. So we want to be able to specify amplitude, maybe attack and decay times. So we'll just start off with some white noise. And to this we'll apply maybe a high pass filter to get rid of some of the low end. Maybe something like 6000 Hertz. Then to this we could apply an amplitude envelope. We'll use the percussive envelope and then these attack and decay times from the arguments. And we'll set the done action to free solve, so this synth will be freed immediately after the envelope is done playing. And finally we'll multiply by the amplitude value. And then we'll make the outputs. For making these outputs, I've got this custom function here, which is just making sure that the output goes both into Soundflower, so you can hear it, and then into my sound card, so I can also hear it. So let's run that and see what kind of sound it makes. Yep, that sounds like a hi-hat. Then we can get started writing a pattern. Actually, first of all, let's make a clock for this pattern. The pattern is going to run synchronized to this tempo clock. And let's just use, I don't know, 90 beats per minute for now. And we'll make it permanent so that it will survive whenever I stop this running synths and patterns. There, and then we'll start defining a pattern for the hi-hats. We'll just use pbind. Instrument is the hat synth we just defined. The duration could be, let's say, a 16th note, so that's a quarter of a beat, 0.25. And oh yeah, we'll have to put the amplitude here as well, and attack and delay. Decay, sorry. This should now give us a very, oops. Alright, I can't use colons here. So now I should be able to play this on our tempo clock. Yep. So then for the Risset rhythm, we want to be able to change the tempo as the pattern goes on. There's probably several ways to do this, but the way I like to use is to have a separate pattern controlling the tempo. So we'll call this tempo. Make another pbind. type rest because we're not going to make any actual notes with this pattern. Duration, that could also be 16th notes, so every 16th note will change the tempo. Let's maybe define some variables to help us with this. So for the Risset rhythm, we want a start and an end tempo, after which it kind of loops. So let's go with BPM 0. This will be the starting tempo. Let's use the 180 beats per minute. BPM 1, the ending tempo. Just make it half of that, so 90 BPM. We could also define how many 16th notes or steps it'll take to go from the beginning tempo to the ending tempo. I'll go with 64. So that's 4 bars, I think. 4 times 16, yeah. Then we want to basically run some arbitrary code whenever one of these events of the tempo pattern gets triggered. So for that we can use collect. Collect gets as an argument the event, and we're going to return that event in the end. But before that, we want to do something with the tempo. So basically, this is the way you change the tempo of a clock. Somehow we want to be able to keep track of which step of the 64 steps we're on currently. So for that we can define here key, let's call it index, and we'll make that a P sequence, and that'll go from 0 to steps -1, so 63, and it'll repeat infinitely. Well, before we continue, let's just see that this actually does what we want. Is this the way to see events? Yeah. So we have these events coming in every 16th note, and after 63 it resets back to 0. Then in here we want to compute the new tempo. So let's make a variable. So the new tempo should be scaled between BPM 0 and BPM 1, depending on the current value of index. What we can do is from E we get the index value. Then we can use, for example, lin-lin, linear to linear scaling. So we'll go from a range of 0 to steps to a range of BPM 0 to BPM 1. Actually, let's call this BPM because SuperCollider tempos are beats per second, so we'll have to convert that for the clock. So then here we just say BPM divided by 60 to get the beats per second value. That should do it. And now we want to be able to run the tempo pattern and the hats pattern in sync. So for this we want to use quant. So quant is for synchronizing these events to specific beats of the clock. So we'll make sure that both of these start on like the next whole beat. Yeah, this is the intuitive way, but there is a bit of a problem here, which is that we want this code here to run before each event of the hats pattern gets triggered. And if we do it like this, then there's no guarantee of which of these will run first. So for this, instead of just giving the quant number, we can use a quant object and pass a timing offset, which will make sure to trigger this event the amount of time before the actual quant that is specified here. That is probably not a very clear explanation, but if I write here 0.01, then it means that each event of this tempo pattern will be triggered 0.01 beats before the actual beat. So that should make sure that it runs right before the event of the hats pattern. And in addition to this, I like to reset the beats value of the clock. We could set this to 0, but the problem with that is that then this won't run until right before the next beat. So what we can do is set negative 0.01 here. So then both of them will start right away. Okay, let's try running. Yep. So you can hear that each 16th note is slightly slower than the previous one. Actually, instead of using a linear range here, I think maybe an exponential one might be better. I mean, it's a matter of taste, but somehow it makes more sense to me. Let's see if we can hear the difference. Sounds kind of similar, but the exponential range is in a way smoother, I guess. If we wanted to go from slower to faster, we could instead flip these two around. But let's not do that yet. So the thing about this pattern is that, okay, you can hear it slowing down, but it doesn't have this kind of looping characteristic that the Risset rhythm has. So you can hear that it's starting over. It's not like a smooth progression. So for that, we might want to tweak the hats pattern, for example, to change the amplitudes of the notes. So what I would like to do is I would like to have the pattern to start with 8th notes. So every second 16th note gets skipped, and then as the pattern progresses towards the end, towards the tempo reset, then the 16th notes slowly come in. So then what happens is that at the end, where you have the half tempo, you have 16th notes playing, and then right after that you double the tempo again, but then you only have 8 notes playing, but then because you have a double the tempo, it sounds like 16th notes, so it's like a smooth transition back to the looping point. So how would we do that? Well, first of all, in the hats pattern, we would like to know the current index value of the tempo pattern. One way to do that is to, in here, in this function, we can just store the index value in a global variable. So we'll just say tilde index is event.index. Then we can use tilde index here as well. And so now we can use that variable in this pattern as well. We'll want our amplitude to go from something like this to this over the course of the 64 steps. I'll define some amplitudes here. Let's put 0.1 here. Actually, I can make it maybe a bit louder. And then amplitude 1. We could put 0, but I want to put an exponential progression from one to the other, and 0 values don't work well with that. Let's just do something like amp 0 times, I don't know, minus 70 dB decibels. That should make it practically silent. So then how do we put this interpolation depending on the index variable in the amp pattern? Well, what we can do is we'll make a P sequence, infinitely looping. For each value of this, we'll pass a 2-element array of amplitudes to interpolate between. So the first one, well, it's always going to be amp 0, so we'll just interpolate between amp 0 and amp 0. The other one is going to be amp 1 to amp 0. And now to do the actual interpolation, we can use collect on this pattern. As an argument, we'll get the amplitudes. So then we want to access the index variable, which we set in the tempo pattern, and interpolate that linear to exponential from 0 to steps, from the range 0 to steps to the range first element of amps to second element of amps. And I think that should do it. Let's give it a try. Yep, there we have it. Basic Risset rhythm. We could try to make this a bit more interesting, add a bit more dynamics. So what I'll do, I'll add a third amplitude value. This will be something in between these other two. So let's say 10 decibels quieter than amp 0. Then we can make this amp pattern a bit more complex. We'll have this go from practically silent to the slightly quieter amplitude. This one go from the slightly quieter amplitude to the full amplitude. And then for the last one, we'll just copy this. It'll start off with 8th notes, where the first one is full amplitude, the second one is a bit quieter. And then when the 16th notes in between come in, it kind of morphs into this same pattern that's between the two 8th notes. Let's hear what this sounds like. Yep, I like this. There's a bit more dynamics. Maybe we could actually tweak this one a little bit. Yeah, I like that. So it's like it's slowing down forever. We could go the other direction as well, where it will seem to be speeding up forever. I think the easiest way to do that is just flip around the index variable. So in here, we'll subtract the current index from the maximum index, which is steps minus 1. So now if we run this, we should get a Risset rhythm that's increasing in tempo. Yep. Maybe I would actually tweak this silence value a little bit as well. I mean, this is just fine tuning. You could spend forever on this. Yeah, there we go. We could maybe use some more interesting sound for this than the white noise hi-hat. I'll take this percussive glitch sound. There's a bunch of random stuff going on, and then feedback oscillator, FFT transformation, and we're using phase vocoder, scrambling the FFT bins. Okay, so I'll run that synth dev. And now, instead of hat, we'll run glitch. Let's hear what that sounds like. I think I prefer the slowing down version actually, so I'll comment this out. Yeah, this is actually sounding kind of like the Autechre tune, Fold4 Wrap5. And we could play around with these variables, like make the step count shorter. So yeah, so you could start building an IDM beat on top of this with some other percussions, synths. Of course, it might be a bit difficult to compose for this kind of thing where the tempo is slowing down and resetting. Like if you want to make it sound smooth all the time, then you have to do these kind of fade ins and outs like we did here.